Welcome back to the AdBlue explanation series. In this final episode, we're completing the last steps of the system design. You'll see how the piping is optimized, how filters and pumps work together, and how the whole unit connects into storage safely and efficiently. Let's finish this project with clean routing, logical decisions, and a smart industrial layout. Let's get started. Just connecting the hot water tank with the reactor. The tank seems to be in the right position. We only need to stretch the heating line to reach it cleanly. Now we have a few open ends here, so let's clean them up and finish the connection smoothly. Now stretching a line from the reactor discharge and returning it back into the reactor's top nozzle to close the loop. I'm drawing this line below the existing pipe routing, keeping it lower to avoid crossing and to keep the layout clean. Now we'll tidy up this pipe unit and organize the routing to make it cleaner and more consistent. Just adding a valve on this side to block flow coming from the filter. This keeps the line short and prevents AdBlue from standing in the pipe. Now I'm connecting the reactor directly to the discharge pumps, so we'll have the option to empty the reactor straight into the truck. Just arranging the valves to make the layout look cleaner and more balanced. Here we can simplify the layout by taking the line from the elbow instead of adding another T. Now let's move this pipe end to a smarter place, not right in the middle of the walkway. Because this line is used only for draining, I'll reroute it directly to the drainage pit. Drainage pits are usually located near walls or in corners, so I'll route this line there. Now I'm connecting the discharge pumps to the drainage pit for emptying. I can see that this outlet line is too short to fit a valve. The simple solution is to extend the pipeline slightly. Just adding a few fittings to clean up these open ends. Now it's time to take a look at the hot water tank. I'll delete a few pipes and then select the entire unit to move it. This tank and pump rotation looks more optimized. I'll leave enough space for access near the storage tank valves. I'll move it a little closer to the wall. so as pump. Now let's tidy up the lines around the tank so they run more neatly. I'll modify the flow meter line so the inline instrument is positioned at hand level. It's very important to leave straight pipe lengths before and after the flow meter to ensure accurate measurement. Elbows, valves, and other fittings create turbulence that can distort the flow profile. By keeping enough straight distance on both sides, the flow becomes stable and the flow meter can work as intended. This helps avoid measurement errors and makes the readings more reliable in real operation. An automatic valve placed after a flow meter requires a long, straight distance. In some cases, this distance can be as much as 20 times the pipe diameter. The valve causes strong flow disturbances, so extra straight length is needed to protect measurement accuracy. That's why valve and flow meter spacing is always checked against manufacturer recommendations. Here I'll just adjust the direction of the water supply line nozzle. This video concludes the AdBlue explanation and layout optimization series. We now have a fully optimized plant layout with cleaner piping and better equipment arrangement. In the next video, I'll walk through the complete AdBlue production scheme using the 3D layout model. There will be no drawing, just a clear 3D walkthrough explaining the process and the technology step by step. Thanks for watching.